Okay, so we are going to be creating a blueprint class in this empty project that I just created. This is a blueprint only project, and I created it without starter content. Um, it's worth mentioning that I have Visual Studio installed, and you're going to want to have Visual Studio installed too. Um, it's free. You can get the 2017 Community Edition on Microsoft's website. But you want to get that set up before you start diving into any C++ code. So first things first, we'll create a blueprint class. And we'll do that by right-clicking on the content browser and selecting Create Basic Asset Blueprint Class. This should be something that most people who've worked with Unreal Engine before are familiar with. But if not, that's how you do it. And you need to select a parent for the class. In this case, I'll pick character because it's a pretty useful type of class. You can walk around with it and all that. So I'll click character and I'll say my BP character. So that's it. It's pretty easy creating new classes in Blueprint. But how would you do that same thing in C++? Well, it's not that difficult. You can do it from the editor, and you can actually do it even if you've created a Blueprint-only project. So the way you do that is by going to File and going down here to New C++ Class. And on the tooltip you can see it says that the code can only be compiled if you have Visual Studio installed. So that's why you'll want to be doing that before you go any further with this. Click on that and it brings up a new window that's very similar to the Blueprint one, where you choose the parent of this class. We want character, so we'll pick that. Click Next and set a name for it, and we'll say my CPP character. And we're going to click Create Class. And this could take a moment. But when it finishes, it should automatically open Visual Studio and present you with two files, mycppcharacter.cpp and mycppcharacter.h. This is pretty common for C++. In Blueprint, you have a single class. However, in C++, you have two files, the header and the CPP, but both of them are used for a single class. And it's actually a little weird because this file is full of text and we haven't actually written any code yet. What's happened here is that Epic has given us some auto-generated function declarations, things that they felt might be useful to us, like begin play, tick, setup player input component, and a constructor up here. We maybe don't want to use these, but if you go back to the blueprint, my BP character, you'll notice in the event graph that they actually kind of do the same thing. They give you these pre-made nodes for begin play and actor begin overlap and event tick. So I guess they're trying to do sort of similar things in their auto-generated native code that they do in blueprints. And we don't really want any of these in Blueprint either, so we'll just delete them and compile. And how do you delete auto-generated functions in C++? Well, kind of the same way, but there is one extra step. So the first thing you might try to do is just select all the things you don't want and hit delete, and that's fine. But this won't compile, and the reason is because you have to also remove the declarations of those functions from the header file. The header file is kind of where you declare all the things you want to use. and the CPP file is where you provide implementations for those things. So if you delete something from one, you have to remember to delete it from the other, or you'll have compile problems. So we're just going to get rid of all the things we deleted from the CPP, from the header. Matter of fact, we'll even get rid of the constructor. We'll just completely clear this file out and completely clear this one out, so it's just empty. You do still need to have an include at the very top for your header file. You'll want to keep that. So what we have here is a empty class, but it isn't really empty because it's inheriting a character. Just like our blueprint class, if we go to the top right up here, we can see parent class is character. Why does the native have an A in front of it? This is just a naming convention that Unreal uses. A stands for actor. So if you see anything that has an A in front of it, it probably means that it's an actor-derived class. Okay, so we've basically created our class in native, and if we were going to compile our code, everything would just work. But something we might want to try is adding a variable. It's like if you were in a blueprint, you could click plus variable and say, create a Boolean, let's say, my BP Boolean. And hit compile, and that's it. That's all you need to do. So how would you do that in native? Well, if you jump back to your header, you could say bool my CPP Boolean. And at the end of that, you'd put a semicolon. And that's fine. That's going to compile, and it will work just fine in C++. But this Boolean you've created will not be visible in a blueprint. You have to do an additional step to make that possible. You have to add what's called metadata to variables and functions that you want Blueprint to recognize. So to do that, you would add a new line above it, and you'd type uProperty, which is the metadata for properties, and you do parentheses, and this is where you put specifiers. Specifiers tell Blueprint how to interpret this variable. So we kind of want it to be modifiable in Blueprint, so we would put Blueprint read write, and we could put edit anywhere. And with those two specifiers in place, this will now be visible and editable in blueprints. So something else we can do, if we jump back to our blueprint character class, at the moment it extends from one of Epic's character classes, but we have a native character class of our own, so we could reparent this class by going to File, Reparent Blueprint, and we could actually choose our new native character, my CPP character, and hit compile, and we notice that up here it now says my CPP character. And if we click on that, it should jump us straight to our header file. So now these classes are actually linked. Our native class is the parent and the blueprint is the child. This is how it has to work. Blueprint extends from native, but never the other way around. Think of Blueprint as like a layer that's built on top of the C++ code. So that gives us some extra flexibility. We should be able to see this Boolean, my CPP Boolean, inside of my BP character, right? Because it inherits from it. Well, yeah, but there's a couple things we need to do first to make that work. One of them is we actually need to compile the code. So let's go to the compile button here. And this is going to kick off a hot compile, which is a code compile with the editor running. This is actually a pretty dangerous type of compile because lots of things can go wrong. But for something as basic as adding a Boolean, it should be okay. So we click this and pray. Uh-oh. Blueprint read-write should not be used on private members. Ah, something else I should have mentioned. So there's a concept of privacy in C++. It exists in Blueprint as well, but it's not as common. You might have noticed that I deleted the public definition from this header. Without that, everything is automatically private. And unfortunately, U properties don't like being private. So an easy way to get around that is to put the public back. You can also add another specifier to allow private access, but I won't go into that right now. Okay, so if I try to compile again, this time it should be more successful. And it was. Cool. So my booleans, my CPP boolean is still not here, which is weird. Oh, there it is. My CPP boolean. So now we have two booleans, one which we've actually declared here in our blueprint, and we can delete, and one which we've declared here in our native class. And you'll notice that if you try to delete that one, you can't do that because blueprints can't directly modify or cannot remove members of native classes. So that kind of makes sense. And yeah, that's pretty much how you add a native variable and expose it to blueprints, and how you create a native class. So we'll leave it there for now, but in the next lesson we'll go over some more complex things you can do. Thanks.